Hello guys, this is a recording for your senior design project, and I had some time today to work on the optimization model, and I came up with a new formulation. So I want you guys to understand what I did so you can take the model, understand the model, and also expand the model with the extra information that we're gonna get from the clinic, and also for extra physicians, and for, if it's possible, for multiple days. Okay, so what I'm showing on the screen is the original description of the problem. So we have some indexes, some sets, we have some parameters, and we have some decision variables. So the first thing that you need to know is that we added a new variable for W, and W has two purposes. One is to let us know the start time of each appointment, and the second one is to allow us to provide some sequence in terms of when you have a new patient, you know that some of them will require at least two time slots of 15 minutes. So this variable is going to allow us to have that sequence of scheduling this new patient for two time periods. So this is again the original description, and when I use PIJ, I mean that is the number of patients of type J requesting an appointment with Dr. I. That being said, one more thing, I added an extra index for the decision variable. So now you're going to have XIJTL. L is the index that is going to let us know the start time of the appointment. So if we start the appointment at time 1, the value of L will be 1. You will see how that works now with the new formulation. So I'm gonna send you my notes. These are handwritten notes. If you can, one of you should be able to pass these into Word using uh, the equation format in Microsoft Word. So now we're gonna have again the objective function is to maximize the number of patients that we schedule. So instead of using xij TL, now I'm using the new decision variable W. W is just defined for I and J, and L. It's not defined for T. We don't need that index for this new variable. So the first constraint is the same constraint that we had for our original problem, but now instead of using xijTL, we're gonna use wij. But it's again, this is the constraint that makes sure that we schedule the number of patients requesting appointment with Dr. I. So if we have 5 new patients requesting appointments with Dr. 1, then Pij will be equal to that number. Okay, so that's the first constraint. The second constraint is about the same, but now we have that extra index L, which is again for the start time of the appointment. So for instance, you can have a patient who starts, a new patient that starts an appointment at time 1, but that appointment will go and move to time 2. So the appointment will take 2 time periods, time 1 and time 2. So if you have a decision variable that is representing time 2 of the time period, you will have two cases for that time slot. You will have the case in which you're going to have a patient starting the appointment at time 2, or you can have a patient that started the appointment at time 1 and now is taking the time 2 period to complete the appointment. So L basically stands for those appointments who are started at time 1 and need to be continued on time 2. Same case if you start the appointment at time 2 and it is a new patient, so you know the appointment will take until time 3 to be completed. Okay, so if we see X111L1, that means that if this variable equals 1, that means that the appointment started time 1 We are currently at time 1 and we are scheduling this new patient for Dr. 1. If we have X1, 1, 2, 1, 2 for T and 1 for L, that means that we have appointment for Dr. 1 for a new patient. This is the time period number 2, but the appointment started at time 1 because L equals 1. And say that, so this second constraint basically balance the number of new and existing patients per time period. So if we want to make only per time period T, if we want to have only one new patient on that time period for this doctor, or for the whole schedule, I'm sorry, for all the doctors, then we make that Q equals 1. Then we have the constraint that ensures that we only schedule one patient per doctor per time period, which is this constraint. And these two new constraints are actually the ones that are gonna tell the model that we have some sequence, that for new patients you need to have one more time period. So these are the constraints again that are gonna take care of that. If you move to, so right now I'm using page 3 of the PDF document with the formulation. If you move to page 1 and 2, I have expanded or show you in these first 2 pages an example of how the model will look like with the constraints. So constraint number 1, constraint number 2, constraint number 3, I'm only showing you the case in which you have Dr. 1, but you can repeat the process for Dr. number 2. And constraint number 4 is right here. So this is for new patients for Dr. 1. And here we have Dr. 1 for all patients. Okay, so this is the formulation. You can take a look to the document. I also created a spreadsheet for the solver. So this is the spreadsheet. Again, this is the same model. I tested it is working, so you can get a solution for the problem right now. This instance of the problem is just for 8 time periods. And well, something that happened was that I was able to format the Excel spreadsheet very nicely, but I was unable to when I went to the solver. So if you go to solver and you try to select all the decision variables, since the format, I'm only interested on changing the spaces of the variables that are in white. Since the format is in this way, when I try to select all of them for the decision variables, looks what happened. I think the Excel has a limit in terms of the number of cells that you can select at the same time. So all of these are my decision variables. And when you get to, see, close to this number, yeah, at that point you are not able to select more. And still have a couple missing in this table, and then I also need to add this row right here. So that was not working, but I still kept this format because if you need to reference to the format of the simulation, I'm sorry, of the optimization model, in terms of how the decision variables are selected, the constraints are in this side of the model. In this instance, we only have, for Dr. 1, we have 5 new patients, and for Dr. 2, we have for Dr. 2, we have 2 new patients. For Dr. 1, we have 3 old patients, and for Dr. 2, we have 5 old patients. So for that instance of the problem, I was able to formulate the Excel model. and also I was able to solve it. But in order to solve it, if you go to the tab that says solver here at the bottom, if you go there, you notice that I put those decision variables now in yellow. I needed to group them, so these white cells, let me close this, these white cells are represented now by those yellow cells. And now, since they are all together, I'm able to select them all to put them as changing cells in here in the solver. I added the constraints, so the constraints are here, and you needed to specify that you're using binary decision variables. So once you do all that, you click solve, and here's the solution. So even though I have 15 pages asking for appointments, the best or the optimal solution for this problem is that you can schedule 11. If you go here to your WIJL decision variables, this is going to tell you the start times of the appointments. So for instance, for doctor number 1, which is I equal 1, you have a new patient, J equal 1, started at time period 1. Then on time period 2, you have no patients because this patient is going to take that time slot. Then on time 3, you have another new patient. That will take time 4. Then on time 5, you have an old patient, existing patient. Time 6, you have an existing patient. And time 7, you have an existing patient, giving you a total of 5 patients. Then if you go to doctor number 2, which is I equals 2, you have an old patient here, an old patient on time 2, an existing patient or old patient in time 3, old patient in time 4, then you have a new patient on time 5, a new patient on time 7. So I prepared this little table here to show you the schedule. So as you can see, we only have one new patient per time period. And then here, same thing. So the optimal solution is 11. We schedule, 11 patients, and this is how we are grouping them. So for Dr. 1, we are placing all the new patients at the early in the morning, and for Dr. number 2, we are placing them at the end of the morning or in late morning. So I hope this can give you an idea. Now your job is to go try to understand what I did. Make sure that you understand the solver, how I place the constraints, what the constraints means, because again, this is only for 2 doctors. We have more than that in our clinic. We need to make sure that we're gonna have enough capability using Excel. So if we add more doctors, if you are able to solve the problem. If not, I mean, the problem is already formulated. I think we're gonna have to tweak some details, but the the difficulty or the challenging part of the formulation is done. So now you should be able to take this to the next level, take this model, expand it to what is required for the clinic, and try to solve it. So if you are not able to solve the problem using Excel, then you might need to find another software package to solve the problem. Please take a look, make sure that you understand what I did, and please let me know if you have questions. I will see you after spring break. Bye-bye.